We're talking about the characteristics of functions for today. I can identify characteristics of linear functions from graphs and from the context. So when we are trying to identify different characteristics, we're trying to identify values that represent our domain. So what can our x represent? What can our range, our y values represent? What are those meanings in words? So making sure that you understand again that graphs are not just lines. They do have representation. They do have a context that they are relating to. So in this situation here, we have a lawn mowing service. Mallory owns a lawn mowing service, and she borrows $400 from her aunt to purchase a new lawnmower. Hence the reason that the graph is starting at negative 400. You guys can close your computers. You don't need them open at this time. Thank you. Okay, so she is in debt right now, starting at negative $400 at the beginning of her time frame. And then it says the graph is going to compare the number of weeks and her profit as she works her way to paying her aunt back. So every time that she is working, every week that she works and mows lawns, she's earning money and is able to pay her aunt back until we get to 4 weeks. At 4 weeks, we hit $0. Then after that, it continues to go above it. So that means after 4 weeks, she's now going to start earning money for her to keep for herself. But any money that she's earning between 0 and 4 weeks, that money is what's being used to go back and paying her aunt. Okay? So we know from this situation that with our domain, can our domain ever go into the negatives? Why not? Because it's time, it's weeks, right? We cannot have weeks going into our negative. So remember this right here, time and weeks, that's representing our domain. That cannot go into the negative zone. So our domain has to be, in this sense, greater than or equal to 0. It does not have any other value that's going in there. So like what we were doing before where we had a compound inequality, this we don't, because we're starting at 0 weeks and then we are continuing indefinitely, okay? So that's why we can go ahead and put down that x is going to be greater than or equal to 0. Because starting at 0 weeks, we are owing $400, and then every single week after that, we are earning money to pay back our debt until we get to a point where we are earning money for ourselves. Okay, so the meaning in words means that this is the weeks that are being spent mowing. The weeks spent mowing. Right, that's part of her service. That's what the domain is representing. Okay, for our range, we also are represented right here in the money amount, the cumulative profit in dollars. So it's not the money that she is making or charging for her services, but it's the amount of money that she herself is profiting. So to start with, she does not have a profit because she borrowed money. Okay, and again, this is going to represent our range. So from here, we don't have any point that's going to go below the negative 400 because negative 400 is the most that she's borrowed. So we're going to put y is greater than or equal to negative 400. From there, from that point, we're constantly increasing our values here. And again, what it means in words, it's representing the profit, the money that she's profiting from mowing. Okay, so to start off with, she's not profiting until she gets to 4 weeks. After 4 weeks, then she starts making a positive profit. But before that point, she's actually just paying back money. Okay, so our meaning is the money profit from mowing. Okay, so we are making sure that we have an understanding of what these graphs are relating to, not just numbers, but they do have context to them. So when we're talking about the characteristics of those situations, so taking that same situation, our characteristics for here, if we're looking at this information, we can split this graph up into several components. So the first component that we can split it up to is this portion right here, all the way to where x is equal to 4 and then down. This portion, I'm going to go ahead and highlight this in my pink. And what this information is relating to, it's the negative region. And those are the intervals where your function is below your x-axis. So those are when your y values are considered to be negative. So let's write that down. That's called the negative region. And they are the intervals where the function is below the x-axis. So again, that's when the y values are negative. Highlight that a little bit better. Okay. So right here where it says intervals of negative values, that's going to be this entire region right here that we're discussing. So that's when x is greater than 0, but it's also less than 4. Who can raise their hand and tell me again, how would we write this as a compound inequality? X is greater than 0, but less than 4. How's that going to be written? Eker? Which is less than 4. 0 is less than x, which is less than 4. 0 less than x, less than 4 is what your compound inequality is going to be. So at any point when x is greater than 0 and less than 4 is where our negative region is going to take place. All right, then we've got another region. This region right here, and that is going to be considered our positive region. Okay, so notice I'm not highlighting any of this area here because of the fact that that's not where the line is moving from. I'm following the progression of my line, the progression of this graph. That's the reason why I only highlight up until this point, up until the x is actually equal to 4. And then anything beyond that point where x is greater than 4 is where I'm highlighting it in my green. So all the values in which x is greater than 4 is where we're going to have our positive values. So again, that represents our positive region. Let me go ahead and write that up here. And my hand will move out of the way in just a moment. So the positive region of your function are those intervals where the function is above the x-axis. So we're looking for the point in which we are above the x-axis, meaning that our y values are positive. Okay, so you're always focusing on reading your intervals from left to right. So it's mainly pertaining to your x's location. At x equaling this value, at this inputted value, what is it going to equate to for our y, or our output? So that's something else I want to make sure you understand. The reason that we're always focusing on whether y is negative or y is positive is based off of the location of your x. So let's put that down. The interval always pertains to the x's location. Okay, whatever your x values are. So you got to think about reading your graph from left to right. You're going to read your graph left to right. Okay, so you're always moving along that x-axis and what is happening to your y values. So your end behavior in this situation is showing that as your weeks are increasing, what is also happening? your money is going up, right? Your money is increasing. Okay, so that is the behavior that we're noticing. It's what we call a trend. And so you're going to hear a lot of that focusing, that common terminology, trend or trend lines, especially as we get into the later end of our unit with bivariate data. We're going to be talking a lot about lines of best fits and trends that are occurring with what we call scatter plots. So we'll learn more about that later, but same kind of idea. In these linear relationships that we're focusing on, the trend happens to be that as we are increasing in our weeks, we are also increasing in our profit. Okay, so all of this information is just characterizing what the function is looking like, or what it's relating to. So on the next page, on the back, what I want you guys to do is you are going to characterize your function. We're not relating it back into actual context, but we're looking at the function as a line. You're going to identify what your possible domain and range values are. Please note that there are arrows here. Those arrows indicate that it's going to continue going on forever. We can't show that graph forever, but we can show arrows that are insinuating that you're going to continue going this direction and this direction. We don't have specific stopping or starting points, so it's going on forever in both directions. So with that being known, what are your potential intervals for your domain and potential intervals for your range? Then you're going to identify the positive values, the interval of your positives and the interval for your negatives, and as well as your end behavior. So go ahead and do that for this function here. Okay, so the very first thing that I want you to note is the domain. Because of the fact, again, I told you guys that the line goes on forever and ever and ever in both directions, that means you're talking about an infinite range for your domain. So your domain's interval is negative infinity is less than or equal to x, which is less than or equal to positive infinity. Same thing for your range. That range is going to continue going on forever in both directions, so that means that its negative infinity is less than or equal to y, which is less than or equal to infinity, positive infinity. Okay, so infinite, when you've got those continuations, those constant continuation arrows, that is insinuating that you are going on forever in both directions. Okay, so there is no limitations to your domain and range. Now, when we're talking about the the positive interval is going to be when x is greater than 6, because at the line where x becomes a 6 is where we cross the axis. So all points past that are now going to be in the positive intervals. So x is greater than 6. For your negative, it's when x is less than 6. So every point below, or to the left of x being 6, is when we're following into the negative zone for our graph. And then for our end behavior, as our x values are increasing, so are the y values. The y is going to increase at the same consistency as the x increasing. Hence the reason, what type of slope is this? Positive slope. When you've got, so slope is going to be a great way to detail your behaviors. So when you have a positive slope means that x increases, y increases. And the reverse, x decreases, y decreases. They have similar concepts or similar trends that they're following. When you've got a negative slope, they will have opposite effects. If x is increasing, y is decreasing. And if x decreases, y increases. They have an opposite effect to each other, okay? So when you're looking at your lines, those lines, the slope will tell you a lot about its end behavior.